So next we are going to deal with parallel in parallel on shift register. Previously we discussed about serial in serial out shift register with respect to D flip flop. This is a 4-bit shift register, and we had discussed about the 8-bit shift register of a serial in serial out with SR flip flops, right? So right now we are discussing about parallel in parallel out. So this is a 4 flip flop, so 4-bit parallel in parallel out shift register. Why it is called as parallel in parallel out? Look at this data. So this is a parallel in parallel out shift register. The data is entered like this: D3, D2, D1, parallelly in and parallel out. Okay, so this is what we call a parallel in parallel out shift register, we call it as. And this particular circuit also called as serial in parallel out. So I will tell why it is also called as serial in parallel. Let me analyze this circuit first. Let me concentrate parallel in parallel out first. Okay, so we have 2 more inputs here: shift enabled and load enabled. Okay, 2 things here. What is shift enabled and what is load enabled? Let me concentrate here. So before that, note down the difference between serial in and parallel out. Serial in means only a single input and a single output. Parallel in parallel out means 4 input parallelly and 4 output parallelly. So like this, parallel in parallel out, 4 data inputs will be sent into the flip flop parallelly, and 4 data outputs will be sent out parallelly. That is 4-bit parallel in parallel out. Here serial in serial out means single input that will be shifted like this, and it will be sent output. That's a serial in serial out. Okay, so look at this circuit now. So we have 4 flip flops. Okay, so all are D flip flop, right? So we have a clock here. So look at the clock, whether it is a positive edge triggered or negative edge triggered. Look at this, we have a bubble, so it's a negative edge trigger. So the change of state will occur only during the falling edge. Okay, when the clock moves from rising edge to clock falling edge, high to low, then only the change of state occurs, because this is a negative edge triggered. Okay, so then we have D3, D2, D1, D0. These are the data inputs. We have a multiplexer here. So let me tell why we have used multiplexer here. So D3, D2, D1, D0. These are the data inputs. Q3, Q2, Q1, Q0 are the outputs, which the output will be sent parallelly out. And data input D3, D2, D1, D0. All the data inputs will be sent inside the flip flop parallelly after the clock pulse is given. Once the clock pulse is given, the data which is present in D3, D2, D1, D0 will be sent inside this flip flops, and similarly sent outside Q3, Q2, Q1, Q0, like this. So this is parallel in parallel out. Okay, so here we have one more option, that is serial in, serial in. Okay, we can send the data into this flop in a serial in and send out in a parallel out. Like parallel in parallel out is also possible, and serial in parallel out is also possible, because we can send the data SI. Look at here, serially we can transmit the data to the first flip flop, and similarly we can send the data outside of parallelly out. So when we can able to perform parallel in parallel out, when we can able to perform serial in serial out, that will be decided by this shift enabled and load enabled. Okay, so whenever load enable is 1, shift enable is 0. So whenever load enable is 1, shift enable is 0. So load enable 1, shift enable is 0. The data present in D3, D2, D1, D0 will be loaded into these flip flops. For example, if D3 containing 0, D1, D2 containing 1, D2 containing 1, D1 containing 0, and D0 containing 1, like 0, 1, 0, 1. So once the shift is 0 and load is 1, load is high, this data 0 will be passed to here, 1 will be passed to here, and 0 will be passed to here, and 1 will be passed to here, will be loaded to here. So again the output will be 0, 1 and 0, 1 will be transmitted output. Okay, like this. This is data input, parallel in parallel out. So if you want to perform parallel in parallel out, load should be high, shift should be low. Means shift should be 0 and load should be 1. Then only you can able to perform parallel in parallel out. So if you want to perform serial in parallel out, then shift should be 1, load should be 0. then the data present here will be passed to here. 0 is here, it will be passed to here. The data present here will be passed to here. The data present here will be passed to here. The data present here will be passed to here. Shifting operation will be performed. Once the clock pulse is given, will be whatever the data present in this flip-flop will be sent outside like this. This is serial in, parallel out. So as of now, I have explained serial in, serial out, parallel in, parallel out. Now I am explaining serial in, parallel out. Okay. So shift and load, these are the two things which are going to decide whether the operation has to be performed serial in, parallel out or parallel in, parallel out. Okay, that's it. What else? Okay, look at this table. So when shift and load both are disabled, when both are 0, when both shift and load both are 0, so whatever the data which is already present within the flip-flops, the present state which is previously present data, that will be the output. So if normally the next state will be represented with plus, right? So if both shift and load are both are 0, so none of the operations will be performed. It is going to retain its previous state. Retain its previous state is nothing but whatever the data which is already present in the flip-flop, that will be sent to the output. Q3 will be sent to output, Q2 will be sent to output, Q1 will be sent to output, Q0 will be present. So Q3, Q2, Q1, Q0 refers to the present data. Q3 plus, Q2 plus, Q1 plus and Q0 plus refers to the next data. Okay, when both shift and load both are 0, so the data already present within Q3, Q2, Q1, Q0 will retain its previous state, will be sent to the output. That is nothing but no change. The output never changes because both shift and load both are disabled now. So let me go with that. When the shift is 0, load is 1, it accepts the data from D3, D2, D1, D0. The output will be D3, D2, D1, D0. I just told. So when the shift is 1, load is 0, accepts the data from D3, D2, D1, D0. Okay. When the shift is 1 and load is least bother, don't care means it can be 0 or 1, not a bother. When the shift is 1, Q3 accepts from the serial input. Q3 refers to this. This flip-flop accepts from the serial input. Okay. Then Q2 accepts from the Q3. So this Q3 will be passed to Q2. So Q2 accepts the data from Q3. Getting serial in means the data which is present in serial input will be passed to Q3. The data which is present in Q3 will be passed to Q2, that will be the Q2. And the data which is present in Q2 will be passed to Q1, that will be the output. The data present in Q1 will be passed to Q0. Shifting operation will be performed. And parallelly the output will be sent. That is serial in, parallel out. Serial in, parallel out will be performed only when the shift is 1 and load is neglected. Right shift. So this is how it works, parallel in, parallel out or serial in, parallel out. So they are given in the equation manner. So this is bar, shift, SH refers to shift, and when bar refers to 0. When it is bar, we normally represent it as 0. When both are 0 and 0, so the output is accepted by Q3 and Q2, Q1, Q0. When both are 0, 0, 0, 0, shift and load both are 0, 0, the output is accepted by the Q3, Q2. I mean the present state, whatever the data which is already present. So when shift is 0, load is 1 in all the with respect to Q3, Q2, Q1, Q0. When shift is 0, load is 1, it accepts the data from Q3 accepts the data from D3, Q2 accepts the data from D2, Q1 accepts the data from D1, Q0 accepts the data from D0. Okay, when shift is 1 and we are lost bother about load, so first Q3 will accept the data from serial input, that is what they have written, SI. Okay, then Q2 will accept the data from Q3 and Q1 will accept the data from Q2, Q0 will accept the data from Q1, the same theory. Q3 will accept the data from serial input, Q2 will accept the data from Q3 and Q1 will accept the data from Q2, Q0 will accept the data from Q1. That's it. This is parallel in, parallel out or serial in, parallel out. Okay, the same thing they have represented, the same thing with respect to the waveforms they have given. Look at this waveform. Clock. So this particular circuit is negative edge trigger, so we need to concentrate on falling edge, this edge. falling edge, when the clock moves from high to low. Okay, we need to concentrate from high to low, falling edge. So when the load is 1, shift is 0. Look at here. When the load is 1, shift is 0, accepts the data from D3, D2, D1, D0. So when the load is 1 means high, shift is 0 means low. It accepts the data. Q3 accepts the data from D3, Q2 accepts the data from D1, D2, Q1 accepts the data from D1, and Q0 accepts it from D0. It might be 1, 0, 1, 1. Okay. So that accepting data, this is not shift operations. This is not shift operation. It is directly loading the data. So when shift is high, when load is high, D3, D2, D1, D0 will be sent into the flip-flop. Directly parallelly, they are loading into the flip-flops. Okay. So 1, 0, 1, 1 means, let me assume this D3 is containing 1, D2 is containing 0, D1 is containing 1, and D0 is containing 1. So this 1, 0, 1, 1 will be loaded to these flip-flops. So that is what they are doing here. So now Q3 is 1, Q2 is 0, Q1 is 1, and Q0 is 1. So directly the data is loaded from D3, D2, D1, D0. When the load is high, shift is 0. Right now load is high, shift is 0 when the falling edge. Okay. So next falling edge, look at the next falling edge. Shift is high, load is 0. Shift is high, load is 0. Load is 0, shift is high. So in such cases, data is accepted. Q3 accepts the data from serial input. So if the serial input is 0, okay, if serial input is 0, this 0 will be passed to here, okay, and this data will be passed to here, and this data will be passed to here, and this data will be passed to here. Only the first flip-flop will get the data from the serial input. Second flip-flop gets from first. Third gets from second. Fourth gets from third. Right. Similarly, this data is received from serial input. This I got it from Q3. This 0 I got it from Q2, and this I got it from Q1. So next I go with here. Next falling edge. So again, load is 0, shift is 1. Again it will be continued. So this this I got it here. This shifting and this shifting operation will be performed because shift is 1. Again look at here, load is 1, shift is 0. Now it accepts the data from D3, D2, D1, D0. This is how the parallel in parallel out is going to work, and serial in parallel out is going to work. And we have one more diagram. This is a shift register with an inverted feedback. Why it is inverted feedback? So we have taken a feedback line here. This is a feedback line from not Q1 bar. Q1 bar is nothing but Q1 is not inverted. Q1 bar is inverted. Okay, so I have taken a connections from Q1 bar. So I call it as an inverted feedback. If I have taken a connection from Q1, it's just a feedback. So we have taken a feedback line from Q1 bar. So it's inverted. Bar refers to inverted, right? So it's a shift register with an inverted feedback. So we call this particular circuit as look at here. Where is this? Johnson counter, twisted ring counter, or ring counter. 3 names. Johnson counter. We call this particular circuit as a Johnson counter, or twisted ring counter, or a ring counter. So you can expect this particular question. So you can see the previous year question paper. This particular question has appeared number of times. Okay, I will just explain how this particular is going to work. So look at this, the same thing I have written. So first state, initial state, it will be 0, 0, 0. If D1, D2, T3, this is Q3, Q2, Q1. This is Q3 bar, this is Q2 bar, and Q1 bar. If Q1 is 0, what is Q1 bar? This will be 1. This 1 will be sent back to D3. So now D3 is 1. So if D3 is 1, this will be 1, 1. So after giving 1 clock pulse, the data present here will be sent here. So the data present here will be shifted here, and the data present here will be shifted here. So the first it was 0, 0, 0. Now it is 1, 0, 0. The second state. Again, let me give the clock pulse. Again let me give the clock pulse. Now it is 0. Again the Q bar is 1. Again I am going to send it here. Again D3 is 1. So again this will be 1. This 1 will be shifted to here, and this will be 0 will be shifted to here. So next state will be 1 1 0. Again after the clock pulse, this 0 is Q1 and Q1 bar is 1. This 1 will be sent to here. This one will be get inside this flip flop. This one will be shifted to here. This one will be shifted to here. So right now all the flip flops containing 1 1 1. This is, if Q1 is 1, Q bar will be 0. So 0 I am going to send it to D3. So if D3 is 0, now it will be 0. So this one will be shifted to here, and this one will be shifted to here. Next state will be 0 1 1. Okay, now again this is 1, again 0 will be transmitted here, this is 0, and this 0 will be transmitted to here, and this 1 will be transmitted here. So 0 0 1. So again transmit here, again you are going to get 0 0. So it's a ring. Okay, first start with 0 0 0, next 1 0 0, next 1 1 0, next 1 1 1, next 0 1 1, next 0 0 1, next 0 0. So we call it as a Johnson counter, a twisted ring counter, or a ring counter, or twisted tail counter. So you can expect this question as well. So next we're gonna deal with the binary counters. We shall start with the counters. So far what we discussed is of resistors, shift resistors, serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. Okay.